Hey everyone, and welcome to this explainer. I'm so thrilled you're tuning in because today we are completely demystifying version control. Look, if you write code, if you work with text files, or honestly, if you manage any kind of digital project, mastering Git and GitHub isn't just a nice-to-have skill anymore, it's an absolute, non-negotiable necessity for your daily workflow. So we're going to take a super focused, really enthusiastic approach today to break down exactly how you can master what is essentially the ultimate time machine for your code. Let's get into it.
Okay, quick question. Have you ever overwritten hours of absolutely perfect code? Or, I don't know, maybe a client asked you to revert back to a version of a site you built like 3 weeks ago, and you suddenly realize it's completely gone? No way to get it back? It is a universal nightmare for anyone who builds things on a computer. You get that sinking feeling in your stomach thinking you've lost your hard work forever. But that is exactly the problem Git was built to solve. It literally acts as a digital time machine. It keeps every single version of your files safely stored so you can just travel back to any previous state without losing even a single line of code.
Okay, let's dive into this. Here is our roadmap for today. Number 1, Git versus GitHub explained. Number 2, the local Git workflow. Number 3, branching in the cloud. And finally, number 4, avoiding common Git mistakes. All right, kicking things off with section 1, Git versus GitHub explained, clearing the confusion right out of the gate. So the crucial point here, and this trips up so many beginners, is that Git and GitHub are absolutely not the same thing. They're deeply connected for sure, but they are completely different tools. I like to think of Git as the coffee itself. It's the core substance, right? The actual version control software that runs locally on your own laptop to track your project's history. GitHub, on the other hand, well, that's the coffee shop. It's the cloud-based hosting service where that coffee is served up, shared, and enjoyed with your entire team. So Git tracks the work on your actual machine, while GitHub is that central hub up on the internet where everybody can upload and combine their work into one single place. And here is why Git itself is just so incredibly powerful. Git runs locally, 365 days a year. Morning, noon, or night, it is constantly keeping track of every single change you make to your files. It meticulously records exactly what changed, when it was changed, who changed it, and where the change happened. And the best part? It does this not just for code, but for literally any file in your project folder. It's basically always watching over your project locally, giving you this infallible 24/7 safety net. That brings us right to section 2, the local Git workflow, tracking how files move from your working directory over to the repository. And this brilliantly illustrates how Git actually tracks your changes under the hood. It's not magic. It's a very distinct 3-step process. Step 1 is your working directory. This is your active workspace where all the action happens, where you're actually typing and modifying your files. But Git doesn't just auto-save these changes. When you're ready to bundle some changes together, you use a command called git add to move them into step 2, the staging area. Think of the staging area as a temporary holding zone, or like a prep table in a kitchen. Finally, for step 3, you run the git commit command to permanently save those prepped files right into your local repository. Now, what's really interesting about this slide is understanding what a commit actually is. When you run git commit, you aren't just hitting save on a document. You are literally pressing the shutter button on a camera. A commit creates a permanent, unchangeable snapshot of your entire project's exact state at that specific fraction of a second. As you make more and more commits, they act exactly like save points in a video game. If you somehow completely break your code later on, no big deal. You can just warp right back to one of these pristine working snapshots. Now you might be wondering, how does it keep all these snapshots perfectly organized? Well, Git acts like a highly rigorous digital filing cabinet. Every single time you make a commit, Git generates this unique 40-character identification hash. It'll look like a random string of numbers and letters, something like 68E80D2. That hash is permanently glued to that specific snapshot, along with your author name, the date, and your message. It's this exact mathematical precision that allows Git to track the chronological sequence of your project's history without ever dropping the ball or getting confused. But hang on a second, what if you have files you absolutely do not want Git to track? That's where the .gitignore file comes into play. You can think of it as an invisibility cloak for your project. By just dropping file names or folder paths inside this .gitignore file, you are explicitly telling Git, hey, look the other way, pretend these don't exist. This is absolutely crucial for hiding sensitive data. We're talking API keys, environmental variables, or massive auto-generated folders like node modules. Seriously, if you don't use this, you run a huge risk of accidentally exposing your private passwords to the entire internet.
Move in right along to Section 3, Branching and the Cloud. This section is all about safely testing features and sharing your code with others.
Okay, so by default, your Git snapshots progress in a very straightforward chronological line. We typically call this the main branch. You start off with an initial commit, right? Then you do some work and take another snapshot when you add your HTML. Then another one when you add your CSS. Everything is neatly stacked one right after the other. But what happens if you want to experiment with a really risky new feature and you definitely don't want to break this perfectly stable timeline if things go wrong?
Let's move to and see how this builds into what is arguably Git's greatest superpower, branching. A feature branch is essentially you creating a parallel universe for your code. You diverge from that main branch and you create a safe, completely isolated workspace to test out your wild new ideas. You can make all the commits you want in this alternate timeline. If the code breaks and everything catches on fire, who cares? Your main branch remains completely untouched and perfectly functional. But if your new feature works beautifully, you just merge those changes right back into the main branch. It keeps your workflow so incredibly clean.
All right, so once your local code is looking great, it's time to send it to the cloud, taking it from your local Git up to the GitHub coffee shop we talked about earlier. You do this using 3 essential terminal commands. First up, git remote add origin. That links your local repository on your laptop to the specific web address of your GitHub repository. Second, git branch-m main. Just ensures your default branch is correctly named main. And finally, git push-u origin main. Physically uploads all your snapshots from your computer right into that cloud repository. Just like that, your codebase is safely backed up and totally ready for collaboration.
Let's wrap things up with Section 4, avoiding common Git mistakes. This is all about proactively protecting your time machine so you don't accidentally break it. Look, even super experienced developers can fall into traps that cause major headaches for their teams. These are what we call the cardinal sins of version control. First up, committing large binary files or sensitive data. We touched on this. It completely bloats your repository and creates massive security nightmares. Second, executing a force push, which is git push -- force. Do not do this lightly. It literally rewrites history and can completely wipe out the hard work of your teammates. And third, committing straight to the main branch, instead of using those awesome feature branches we just talked about. Doing that can instantly inject totally untested bugs straight into your stable production code.
But hey, the good news is there are perfectly safe alternatives for all of these. Instead of doing a dangerous, destructive force push, you can use git push -- force with lease. It's a brilliant little command that just double checks to ensure no one else has updated the remote branch before you go overwriting things. And rather than committing straight to main, you should always push your feature branches up to GitHub and open what's called a pull request. A pull request is exactly what it sounds like. It allows your team to review, discuss, and approve your code before it is safely merged into the main branch.
Oh, and here is another massive pitfall: leaving lazy, totally uninformative commit messages. Just imagine trying to look back at a commit you made 6 months ago, and the message just says, updated stuff. I mean, that tells you absolutely nothing. Instead, you want to use strong, imperative commit messages, like fix bug and login feature. A great commit message clearly and concisely summarizes exactly what that specific snapshot does. Doing this turns your Git history from a messy list into highly readable, genuinely useful documentation.
And that perfectly leads us to our final thought for this explainer. At the end of the day, your codebase is quite literally a history book. Every single time you type git add and git commit, you are actively writing a brand new page in that book. By mastering local tracking, understanding how to branch effectively, leveraging GitHub for teamwork, and steering clear of those destructive cardinal sins, you ensure your project's history is secure, it's clean, and it's ready for collaboration. So I'll leave you with this one question to ask yourself the very next time you sit down at your terminal. Your codebase is a history book. What story will your commits tell? Thanks so much for joining me on this explainer, guys. Now get out there and write some amazing code.